started. Welcome everyone to the Ontology Summit 2025. I'm Ken Wislowski. I'm the chair of the Ontolog Board of Trustees. And today is the 29th of January, 2025. The theme of our summit this year is conceptualization, analysis, and formalization, the two sides of ontology, relating ontologies to the world and to theories about the world. So we're looking forward today to a presentation by Giancarlo Guizzardi, who is going to be introduced by our track chair, Gary Bergcross. Gary, could you please take over?
Yes, thank you, Ken. I am Gary Bergcross, the organizer of Track 1, and it's a great pleasure to welcome Giancarlo Guizzardi back to the Ontology Summit. Giancarlo was, for example, part of the Ontology Summit in 2012 on the topic of ontologies for big systems, and his talk then was entitled An Engineering Approach to Ontology Engineering in Complex Environments, the Role of Foundational Theories and Ontological Patterns. And that talk reflects one of his many insights about foundational ontologies and semantic integration, and makes the argument that work that neglects the role of ontologies as reference conceptual models cannot meet the requirement of supporting full semantic interoperability. His most cited work and thesis work from 2002 is Ontological Foundations for Structural Conceptual Models, and this reflects thoughts about improving ontological adequacy. An updated bio for Giancarlo can be linked to on our site. Briefly, he's now a full professor of software science and evolution, as well as chair and department head of semantics, cybersecurity, and services at the University of Twente in the Netherlands. He is currently also an affiliated guest professor at the Department of Computer and Systems Science at Stockholm University, and a guest professor at the Technical University of Vienna, Austria. Of special interest to this community is that he is the main contributor to the Unified Foundational Ontology, UFO, and to the OntoUML modeling language along with its tools. He is also a member of the advisory board for our professional organization, the International Association for Ontology and its Applications. Building on the foundation provided by Nicola's keynote last week, his talk today, as part of Track 1, looks at the relation between the notions of real-world semantics, ontology, and explanations, and has explanations as the first part of the title, the aptly titled Explanation, Semantics, and Ontology. I should add, as was true for our keynote session, people may use chat for comments and questions, and we expect that there will be some time for questions and answers following the talk. And with that, please welcome Giancarlo Guizzardi back to the Ontology Summit.
Thank you very much, Gary and Ken. It's a real pleasure to be here. I didn't realize it was so long ago, almost 15 years ago, that I participated in the summit. So it's great, really great to be here. So this talk, so the title, Explanation, Semantics, and Ontologies, is the title of this paper that we wrote together, Nicola and myself. So it's a nice segue to the keynote last week. And it's also a kind of philosophical joke, it's a reference to Carnap's paper, Empiricism, Semantics, and Ontology, although the paper goes in a completely different direction, of course. So we do four things in this paper. So first, we show that these notions of explanation, semantics, and ontology are intimately connected, right? So in a sense, it's very hard to have one without the other. We revisit the literature on explanation that you have in philosophy, not only metaphysics, so you have things like, grounding explanation or truth-making explanation, but also some other notions that we're going to see here today. The unificatory approach, the pragmatic approach to explanation, in particular, something called the ontological approach to explanation. We revisit these things and we found we propose a way to operationalize all these different theories of explanation in terms of of a method, a methodology for explaining, in particular for explaining symbolic things, right? And this connects to the third thing we do in the paper, which is to revisit the literature on explanation in AI, in explainable AI, and to show that what people are doing there is not really explaining. And fourth, we also show that by using this method of explaining, which we call ontological unpacking, we change the nature of the artifacts we are explaining, right? So we have all these different symbolic models, logical theories, knowledge representation artifacts, knowledge graphs, domain ontologies, and so on. Our claim is that most of the artifacts we find out there are merely descriptive. And that by using a method such as the one we are proposing here, we change these models not only in terms of their expressivity, but also in terms of their nature. So instead of having just a descriptive nature, we get in the end an explanatory artifact. So I think, to this community, I think the main message of the talk will be, the project of ontology engineering is an explanatory project, and there is an immense opportunity for the work we do in this community with explaining data structures in general these days, including AI artifacts. So let's start in the beginning. And I will start with this cartoon that I like very much. Tom Goldis, he writes for The Guardian and New Scientist, one of my favorite cartoonists. If I had to summarize the whole talk in one slide, it would be this one, right? So we have here, the pig comes to the other pig and says, have you noticed that the farmer has been using the words ham, bacon, and sausage a lot lately? Then the other pig says, yeah, what do you think they mean? And then I'm going to find out. And then pig goes to the library, comes back, says, Maurice, I got some really bad news. So if you understand what's going on here, if you understand the implicit joke, it's not because of the data here. It's not because of anything you see in the slide. In order to understand what's going on and to explain what's going on, you have to review the ontology behind the data. In a sense, you have to understand that ham, bacon, and sausages, these are pork-based products, so it has some constitutional relation to an amount of matter that is pork, and that bears a historical dependence relation to individuals of the type pig, and unfortunately, Maurice and his friends are instances of the type pig. So at least you need to understand that. You need to understand a little bit about the intentions of the farmer and so on, right? But none of these things, this worldview, this world in the background that you need to understand the joke is here in the cartoon itself. So this idea that so this is a description, right? It's a symbolic artifact. And the claim I would like to make, which is actually an observation, is that any artifact, which is not just a piece of mathematics, so that has more than just formal semantics, that has what is called the real world semantics, will make an ontological commitment. So this is, for example, the subway map of Amsterdam. In order for this thing to make sense, this is a knowledge graph, if you like, for this thing to make sense, we need to map the symbols here into an ontology of subways and a particular instance of that ontology, right? So there is a worldview here in the background. You need to believe that there are things like, lines composed of stations ordered in a certain way, having directions, intersecting lines, and so on. So this thing only acquires meaning by mapping this structure to a given ontology of subway stations. Of course, this is true for all information systems. So even the most mundane of databases like this one, for example, dealing with transplants, quote unquote, believes in a world in which there are people who can be living or deceased, but not both at least one of those, but not both at the same time, that once you are deceased, you do not go back to being living, as far as we know. That there are transplants, and transplants can only exist by binding things like surgeons, donors, and donees, and these things bear certain relations to the type person, some relations to people. some identity relation to instance of people at the instance level and so on. So this database embeds a given theory of the world. So I think this is connects well to a notion of a Quinean notion of ontology, right? That the ontology, in a sense, is like what the world has to be like in order for your description to make sense. So what kind of things you assume to exist in the world for your description to make sense. This idea of ontology and ontologies is actually goes back to the first reference to the word ontology in computer science, the paper by George Mealy, Another Look at Data from 1967, in which Mealy, by the way, makes a reference to Quine, and Mealy is kind of complaining. Mealy is, by the way, the PhD supervisor of Peter Chain, right? So the creator of the whole community of conceptual modeling. And he's complaining a little bit that, computer scientists are a bit obsessed with symbol manipulation. And he's saying, we need to pay attention to the relation between the symbols and reality and the world and conceptualizations of reality. So data are fragments of a theory of the real world, and data processing juggles representations of these fragments of theory. So this is an issue of ontology, or the question of what exists. So this is the sense of ontology that I'm using here, right? Ontology, not so much as an artifact. Of course, we can have representations of what I'm saying here, but I'm using ontology, lowercase o, as a theory about the kinds of entities and their ties that are assumed to exist by a given description of reality. Now, when we think about data management in practice, and we have reference models like this idea of the 4 V's of big data, it's quite clear to everyone by now that the 4 V's should not stand in the same footing. That the real problem there is dealing with variety. So the fact that data exists in a diversity, both from a synthetic and semantic point of view, and the issue of veracity, which has to do also with the mapping between the data and the things in the world that the data is supposed to represent. Dealing with these things is fundamental because all the essential things, all the essential questions we need to have answered in science, in government, in organizations, can only be answered if we put together data which now reside in autonomously developed information silos, right? Now, if we have that every single database, every single information system, even every single program makes an ontological commitment, the task of relating these different artifacts is actually the task of relating their ontologies. So the different worldviews which are embedded and represented in these artifacts. So it's finding out, for example, how, if I have these two databases, one dealing with transplant on the left and transplant on the right, is finding out what is the relation between these two different ontologies or these two different worldviews. Can I assume that person on the left is identical to person on the right just because I'm using, let's say, the same lexical term? What about transplant, right? Can I assume that transplant on the left is the same as transplant on the right? So if not one relation of identity, so what are the alternatives, right? Parthood, specialization, manifestation, causality, instantiation, dependence, which kind of dependence, generic dependence, specific dependence, historical dependence, well, existential dependence, historical dependence, and so on. So, and once I find out what that relation is, then I have to understand what that entails, right? So, for example, if it is a relation of identity, we know identity is an equivalence relation, and it's also a relation that should, obey Leibniz law. If two things are identical, they have the same properties necessarily in all possible worlds. So the problem of interoperability, at the end, consists in these 3 tasks. 1, revealing the ontology embedded in an information structure, finding out how these different ontologies relate to each other, what kind of relations relate to the different elements in these different ontologies, and 3, understanding what that entails so that you can actually code something that would reflect that. And in order to do that, to do these three things, we need ontology, capital O, so an area devoted to developing these domain-independent toolboxes with tools for supporting ontological analysis. Now, coming back to how this connects to explanation. So in a sense, suppose that, again, this is a kind of knowledge graph, right? This is a description of what I have there in the subway of Amsterdam, given a certain abstraction level, a certain perspective, and so on. But suppose I want to, go from Sloterdijk to the Pijp, and I ask someone, and they tell me, take the 50th line in the direction heen, and then you stop in Amsterdam Zuid, and you take the blue line in the direction north, and you stop in the third station, right? That would be an explanation for this, a kind of topological explanation for my question, for my request for explanation. And why would that be a good explanation? So what is there that makes this a good explanation? Well, it's the actual relations between these things in the world. The fact that these lines exist with these directions, with those intersections, with those ordering and composition of stations and so on. So this idea that to explain is to reveal the semantics behind the artifact, or in other words, to reveal the ontological commitment of a given description, reveal how the world should be like in order for that description to make sense. It's actually also represented in one tradition of explanation in philosophy, which is called the ontological approach to explanation by this philosopher called T.Y. Cowell. So he's working in problems in quantum physics and things like that. But his point is very much the point I'm making here. And although I never use text in slides, or seldom uses text in slides, I think his quotes are just too good not to put it here. So he says, the notion of a basic ontology in a scientific theory refers to the irreducible conceptual element of what is assumed to exist in the domain under investigation. As a representation of deep reality, the basic ontology enjoys a great explanatory power. That is, all appearance should be derivable from it as a result of its behavior. Whenever we have something important but difficult to understand, so here it's an important connection between understanding and explanation, we should focus our attention on finding what the primary entities in the domain under investigation are. Discovering these entities and their intrinsic and structural properties is the real work of science. So this idea, before we move into the, showing you an example of ontological unpacking, just as a very, I would like to appeal to your intuition here. Again, this is a knowledge graph, which means it can be decomposed into a set of propositions, but it's hiding the entities in the world that would make those propositions true. So in this idea of ontological unpacking, what we are doing is moving from a focus on truth bearers, so those propositions that can take a truth value, to the truth makers. So what are the entities that are responsible for the truth value of those propositions, right? Again, just to use a simple example, this is one knowledge graph, says that John works for the University of Bolzano, that John is married to Mary, he's the husband of Mary, Mary is the wife of John, and Mary cannot work for the University of Bolzano, right? It's prohibited to work for the University of Bolzano. Again, a perfect description. It's totally fine as a description, but it has no explanatory power. We don't know what these labels mean. What are the conditions for the truth of these propositions here? To understand what it means for John to work at the University of Bolzano, so why is it true that John works for the University of Bolzano and not for the University of Twente? It's because something in the world exists. A social object, a contract binding John to a legal object, actually, a bundle of commitments and claims and rights and obligations and liabilities and powers that binds, that by being existentially dependent on both John and the university, binds them. Here, what does it mean to say that John is married to Mary? well, there is something, again, in the world, a kind of bundle of social legal positions as the ones I just described, that by being dependent on John and Mary, again, mediates bind them. Now, it's because of this rights and obligations, duties and permissions and commitments and things like that, that we interacting between the two legal objects, that we can explain the third proposition here, right? That it's, for example, part of his contract and under Italian law, that he has a duty to omit to work for any institution that a relative up to the third degree works for. So this is what explains the truth value of those propositions. So the idea here, one of the main takeaway messages in this first part of the talk, is how to move from models which are merely descriptive, that have this function of structuring data or structuring information, of describing things in a given domain, to models that have this explanatory function. In other words, to move from a model that it's a collection of truth bearers to a model that would reveal in an explicit way what are the truth makers of those propositions. By the way, I should mention that the notion of truth-making I'm using here is not the classical notion of truth-making proposed by Barry and Peter Simons and Kevin Mulligan in the 80s. That was a great idea. I love the paper. But we found that from the point of view of explanation, we needed something in a different direction, right? We leverage here the work of a philosopher, a very young late philosopher, unfortunately called Josh Parsons, that proposed this idea that we call weak truth making. So instead of just having as a truth maker a situation in the world that accounts for the truth value of a proposition, weak truth making points to the entities in one's ontology whose changing value flips the truth value of the proposition. So if I say that the rose is red, classically, the truth maker would be a situation in the world with the rose being red. From the point of view of explanation, not very informative, not very explanatory. Here in weak truth making, we would point to what in the rose would account for the truth value of that proposition. So namely a quality, a color quality inherent in the rose, whose change would account for the change in the value of that proposition. Now let's take a look at this idea of ontological explanation or ontological unpacking, right? So I will use the simplest example we could. I mean, we did this on purpose, right? We took a ridiculously simple model with basically two classes and two relations, so almost the simplest model you can find. To show how much a model like this in a domain that is well known, so with which we are all familiar, how much a model like this would reveal a lot of subtleties. So here we have, a person is treated by 0 too many healthcare providers. A healthcare provider can treat 1 too many people, and a person can have a more serious medical condition than a 0 to many other people, and vice versa. So again, this is a perfectly descriptive model, but it doesn't answer any question about what the world would have to be like for these things to be true. So let's do it step by step, right? We take proposition by proposition here. So let's start with this one. What does it mean for a person to have a more serious medical condition than another person? Well, let's suppose that, we have here John and Bob, and that Bob has a more serious medical condition than John, if and only if Bob and John have medical conditions, let's say pathological medical conditions, and Bob has at least one medical condition that is more severe than all the medical conditions of John's. So here are John and Bob. They have these modes that inhere in each of them These modes can take their values in a certain conceptual space. Let's take here a conceptual space of severity of symptoms that we assume is totally ordered. And this is the situation. So this is having those symptoms as aspects, as modes inherent in them, and having their values, their states measured, let's put it in this way, in terms of that conceptual space, with having those values ordered in that way, is what accounts for the truth value of this proposition. Now, this also explains why this relation is a totally ordered relation, right? The relation is totally ordered because this relation is actually reducible to intrinsic properties, intrinsic modes of the relata and their values. And their values are projections into a conceptual space which is itself totally ordered. So here we have an expansion of this model, making clear a number of things, right? So here we have the type person, instantiated by John and Bob, for example. We have their pathological medical conditions, which are modes, which inhere in them. And these pathological medical conditions have certain subtypes, subkinds, diseases and disorders, and there are a bunch of relations here. So let's take step by step. Important bit here is this relation between John and Bob is not really a relation between these two entities. This relation is first reducible to relations between their symptoms, their medical conditions, which is itself reducible to relations between values of those symptoms in a certain conceptual space, right? Again, we have here different types of things. So we have, let's say, endurance that are independent, like Bob and John. We have their symptoms, which are existentially dependent entities. In UFO, these are called aspects. And we have abstract entities like values in a conceptual space. We also have a hidden quality here, which is the severity of the symptom, whose value is a let's call it a qualia in a conceptual space. So here in the background, we have a small ontology, right? So we have concrete entities like objects and aspects. Aspects can be intrinsic aspects like modes and qualities. And like the symptom is an example of the mode, and the severity of the symptom is a quality. All aspects are existentially dependent on other entities. Well, there is a mistake here. They are dependent on concrete entities. And then we have abstract entities like this quality space. Now, here we also have this relation of existential dependence, that binding the symptom and the patient. And here we see three different types of, or at least two different types of relations, right? We have relations which we call comparative relations, so relations which are reducible to intrinsic aspects of the relata. So the relation between people is reducible to relation between the symptoms. The relation between the symptoms is actually reducible to relations between their qualities, the values of those qualities. So relations which are not really, do not really have a relational content, right? They are reducible to intrinsic properties of the relata, in a sense. On the other hand, we have relations which hold directly. So the truth makers of the relation between the symptom and the patient is the symptom. Because of the nature of the symptom, it can only exist by inhering in the patient. On the other hand, also a relation of a different nature, but that holds directly here as well, is the relation between these points in the conceptual space. So what makes true that 5 is greater than 3? The very nature of 5 and 3. So here in the background, we have a typology of relations based on their nature of their truth makers, right? So here, primitive relations, the truth makers are the relata. Then we call this, I'm calling this here grounded relations, so relations that are, the truth makers are not the relata, but comparative relations, the relations are intrinsic aspects of the relata. Here, let's explain what this optional cardinality constraint is doing here, because there are no optional properties, ontologically speaking. So why do you have an optional cardinality constraint? Well, it's because you are hiding certain types. So here a person can be an instance. So all instances of person are necessarily instances of person, but they are only contingently instances of types like being a healthy person or an unhealthy person. So these are called phases, these contingent dynamic types in UFO. And then we say unhealthy people have at least one symptom. So in the background, what we have here is the type ontology of types. Now let's look at this relation treated by. Unlike the relations of being having a more being sicker than, or being taller than, or being older than, which again are comparative relations reducible to intrinsic aspects of the relata, the relation treated by really has a material content. So what makes this relation true, or the relation hold, the relational proposition true, is something which is truly relational in the world, right? A type of aspect which is existentially dependent on the relata, thus binding them and thus explaining the truth value of those relations. So these are called, so relations whose truth makers are relational aspects, true relational aspects, which in UFO are called relators, are called material relations. And these are the majority of the relations in social legal domains, right? So employments, enrollments, marriages, presidential mandates, these are all relators, and they would ground, let's say, material relations. So now let's take this cardinality constraint here, the optional cardinality constraint of this relation, which is much more, well, again, we have to review what's going on here. It's, again, you're hiding a type. So we have here that this relation is not really a relation between people, healthcare providers, but between patients and healthcare providers. And patients are roles played by unhealthy people when treated by healthcare providers. So again, this notion of role here is a dynamic type, but connected to a relational instantiation condition. Again, we're expanding our ontology of types. And this is, let's say, a static, rigid specialization of a kind. Now, let's look at these cardinality constraints. For material relations, and only for material relations, these cardinality constraints are necessarily ambiguous. So if I have here that a patient is treated by one too many healthcare providers, or a healthcare provider treats one too many patients, what does that mean? Right? How do I interpret these cardinality constraints? Again, this relation is a material relation. So what makes true this relation is something in the world, namely a treatment that binds these entities. Now, given that this treatment is hidden in this representation, I have a number of different ways, several different ways of interpreting these cardinality constraints. For example, that given a treatment, there is exactly one patient, exactly one healthcare provider, but both patient and healthcare provider can participate in many treatments. Given a treatment, there are possibly many patients, exactly one healthcare provider, but both patient and healthcare provider can participate in many treatments. Given a treatment, you have exactly one patient, possibly many healthcare providers, they can both participate in one treatment. Multiple patients, multiple healthcare providers, they can only participate in one treatment, and so on and so forth, right? So there are all these different ways of interpreting what does it mean to be treated by in this context, and all these different interpretations collapse into the same representation there. Now, if instead of that, we represent the truth maker, in this case, explicitly the treatment with this existential dependence relations, which are called mediation in UFO, we can make explicit which of this interpretation holds in this given worldview, right? So here we're making clear that, so this entity is called a relator, this relational aspect. Here we have the cardinality constraints of the original relation. Here we're making clear that in this ontology, a treatment binds one single patient, one healthcare provider, but both of them can participate in many treatments. So If you're treated by several hospitals at the same time, these are all different treatments, right? That's what this model is saying. Now, what I'm going to do, I'm going to radically change those cardinality constraints in yellow, and we're going to see that the cardinality constraints of the original relation remain the same, meaning the original relation collapse all these interpretations, right? So I could have a radically different ontology here in which treatments are collective, possibly collective on both sides, but people can only participate in one treatment and the hospitals can only treat one treatment. Seems a bit absurd. Here's another one that you can have collective treatments on both sides and they both can participate in many treatments. But the point is the cardinality of the original relation remains the same. Now, this relation here is called derivation, which is the relation connecting the truth maker to the tuples, which are the instances of the relation, right? And these cardinality constraints here are actually quite useful. So this one is derived, right, from those cardinality constraints, so not very useful. But this one is telling me how many times a patient can be treated by the same healthcare provider. So it gives a kind of back semantics to this relation. So again, by doing this, by decomposing this model in a number of positions and revealing by following these rules of the ontology in the background, the truth makers of these relations, we can transform this model into this other model that is making all these things clear. So again, the difference between these models is not just one of expressivity, but one of nature, right? So you're moving from a mere description to an explanation. I like very much this quote from Bas van Fraassen, a philosopher of science who proposes the idea of pragmatic explanation, says, traditionally, theories are said to bear two sorts of relations to the observable phenomena, description and explanation. Description can be more or less accurate, more or less informative. As a minimum, the facts must be allowed by the theory, fit some of its models, right? As a maximum, the theory actually implies the facts in question. Explanation is over and above description. For example, Boyle's law describes the relationship between temperature and the volume of a contained gas, but it does not explain it. Kinetic theory explains it. So here's the second takeaway message. To explain is to reveal one's ontological commitment. So to reveal the real world semantics of a certain description. And that's what's needed for semantic interoperability. Because again, what we need to interoperate is to connect these different, the ontologies which are revealed by this operation. So just to show a simple example. So suppose I have these two models, two different ontologies in the sense that I'm using here for treatments. And if, had I had just the original representation, if we look in these yellow areas here, you see, everyone would think that you're talking about the same thing. So you'll be, prone to a false agreement because we have the same types, the same relations, the same cardinality constraints. But the semantics of being treated into these two different models are very different. So the ontology, the conditions in the world which constrain the possible instance of these relations are very, very different. I could take this model and unpack this model in a completely different way if I had a completely different worldview behind it. Like, for example, treatments being treated by could be made true by a participation in a treatment event or a treatment process. On the other hand, healthcare providers could be of different kinds. So you could have healthcare providers which are people, and healthcare providers that are organizations. So this would be a very different unpacking of that model. Being treated is to have been treated in these different ontologies, so to have participated in a historical event, because all events are historical events, but that's a different story. This would allow me to see that these different systems that talk about treatments are not talking about the same thing. Of course, there is a relation between treatment on the right and treatment on the left, but it's not one of identity. In some sense, the treatment on the right is a kind of manifestation of the treatment on the left. It's honoring the commitments and claims and rights and obligations of treatments in the other sense, in the sense of the left side. Now, let me briefly go to the third part of this talk. It's impossible these days to talk about explanation without talking about explainable AI. This, of course, would deserve a completely different talk, but I'll very briefly talk about these two different strategies in an abstract level that people are pursuing, trying to achieve this. One is the so-called interpretability framework or the complete model view, in which to explain is to generate what people here call the inherently interpretable models. I find that the name completely absurd. Like we just saw, even tiny models that have a clear formal semantics, they are not inherently interpretable. But anyway, so what people mean here is to generate, for example, a decision tree, right? People are excited because you can generate a decision tree which equivalent to a neural network, and they call this an explanation, right? First of all, I mean, it's obvious that you can do this because a neural network is a function, a complex function, a decision tree is a complex function. We know this for 30 years that this can be done, but the fact that you can generate a decision tree doesn't mean that people understand that there is an inherent interpretation, explicit interpretation for that decision tree, as we just saw. So the idea here is that this idea is grounded on this false premise that to explain is to generate a symbolic artifact. And this is grounded on this idea, on this premise that symbolic things are self-explanatory just in virtue of being symbolic. Again, this is not inherently interpretable or self-explanatory, as we just saw. And this is basically the simplest model one can think of, not a decision tree with thousands of nodes. Now, the other approach is this idea of an explainability framework or the partial model view, in which we explain without opening the black box. The most popular idea here is this idea of counterfactual explanations. One example, you were denied a loan because your annual income was £30,000. If your income had been £40,000, you would have been offered a loan, right? Well, if you would actually be providing a counterfactual here, a counterfactual in terms of elements like loans and annual incomes, explainable in terms of what is the relation between your income, your purchase power, and the credit risk, this would be an explanation. But that's not what really happens in this case, right? And this is made through, this is very well argued in this paper called Semantics and Explanation, why counterfactual explanations produce adversarial examples in deep neural networks. Beautiful paper, in which these authors basically show that because you cannot have in the network a representation of what they call semantically dense dimensions, basically a representation of those concepts, right? In a way that is identifiable, what people do is to tweak the network until you get the result you want, right? And by doing that, you make explanations identical to adversarial examples. There is absolutely no difference between explanations in this sense and adversarial examples. So the point they make, which I wish I had used the slogan before, is that there can be no explanation without semantics, no explanation, counterfactual explanations, without the dimensions in which you're manipulating being having semantics in the sense we are here. So being mappable to real concepts in the domain. Representations in neural networks are not really signs, right? They do not correspond to anything that's interpretable, anything that is metaphysically meaningful. It's not the case that we will be manipulating things like this, like loans and annual incomes and so on. One I'm approaching the end of the presentation, but one thing I'd like to talk about is that, people also in Explain AI forgot that there's a gigantic body of work in philosophy about explanations with criteria for evaluating the quality of explanation. So there are many. I'll just mention these three because they are quite obvious. One, the most basic one is that it's differentiating between knowing that and knowing why, right? And again, if we take the typical black box explanation you find in Explain AI, Shapley values, it's connected to this idea of counterfactuals as well. But Shapley values is you have a number of inputs and you have an output and you have a weight that represent the contributions of these inputs to the output, right? Suppose that you have a bunch of genes and you have the prediction of a certain disease, and these genes somehow contribute with a certain weight to that prediction. How is that an explanation, right? You know that, but you don't know why. So knowing why would again be revealing the ontology behind those that data set, right? Of that situation, that description is connected, saying, these genes participate in the coding of these proteins. These proteins disrupt these metabolic pathways and so on and so forth. In this case, a kind of causal explanation that would connect to the emergence of that disease. Second is, the why regress. So as I just exemplified, so a Shapley explanation still asks for the explanation. So for why those genes with those weights contribute in that way to the prediction. Here in ontological unpacking, for example, in the example I just saw, the regress stops in these primitive relations, right? So you can always explain the model by referring to these categories of relations, for example, because my example was centered on relations, which are self-explanatory because they are primitive, because they are non-analyzable. My headache is connected to me by the very nature of the headache. I don't need anything else to explain that connection. And finally, one essential thing for explanation is this notion of counterfactuality or contrastivity and contestability, right? So in a sense, it's, in a practical sense, explanation is connected to this notion of contestability because you want to falsify certain things if you want to contest the explanation, right? This is also quite nicely put in this paper by Lipton on the right to explanation, that explanations that are, worth its salt is that they must be presented in terms of clear, falsifiable propositions and offer a natural way of contesting those propositions and then modifying the decisions which are based on them. And that's exactly what we get with this notion of weak truth-making. So coming back to my example here. So if you want to dispute that Bob has a more serious medical condition than John, you would come up, you know exactly what you need to do. You need to, for example, show that there is, at least one symptom of John that's more serious than all symptoms of Bob, right? So you know exactly what you have. What are the entities in the world that whose existence you need to dispute in order to falsify this proposition? So the method you get here is that from a description, you extract a number of truth bearers, you find this operation of unpacking is revealing what are the truth makers that account for the truth value of these truth bearers. So in other words, how the world has to be like in order for those things to be true. Then, of course, there is a step of finding out if the world is like that. So finding data which will be evidence of the existence of those truth makers, right? This is, by the way, I could have given another talk on how this could play a role in fake news, right? So these two steps of, if you're disputing a certain proposition about the world, so the first step before we go searching for data, we need to agree on what the world would have to be like in order for that proposition to be true, right? So for example, if you want to say that it's not true that Brazil had an episode of an invasion of the Congress as well. So, and now being prosecuted, and there are a lot of discussions there. So the first thing, in order for people to agree about those cases, they need to agree what the world would have to be like for that thing, for those people to be liable to that crime, right? So they have to agree, for example, that, you know, they are involved if there is a collective plan, they are aware of this collective plan, they are acting according to that plan, and so on and so forth. Then we can agree if those, then we can find out if those things happen or not. But first, in order to have a meaningful discussion, we need to agree that that's how the world would have to be like. So, you know, just to summarize many of these thoughts in a sequence of takeaway message. So all science is data science, right? This is unavoidable. Interoperability is absolutely fundamental for science. We cannot have interoperability without understanding. We need to understand what is represented in our symbols, in our symbolic structures. There can be no understanding without explanation. To understand is actually to explain the phenomenon, right? At hand. This is the title of a beautiful paper, by the way, called No Understanding Without Explanation by Michael Stravens. There is no explanation without semantics, no semantics without ontology, in the sense that I discussed here, no ontology without ontology. I love this slogan by Achille. And, you know, if you buy the 7 steps, then the logical conclusion is that there is no science without ontology. So discovering these entities and their intrinsic and structural properties is the real work of science. That's it from me. I'd love to hear from you. Thank you.
Well, thank you, Giancarlo. Wonderfully rich and thought-provoking. If there's time, I do have a question, but I'd like to start as we did last week, since we have Nicolo, our keynote speaker, and 2 subsequent speakers on this track, to see if they have questions and comments, starting with Nicola, then Michael, and then Barry, who was mentioned in your talk.
I have no questions indeed.
Hi, Nicola.
Okay,
Hi,
Michael.
Oh, hi, Giancarlo. Yeah, as
Hi.
always, great talk, even after hearing a few versions. But I was just wondering, in terms of, say, ontology evaluation, say Nicola brought that issue up to the foreground last week. To what extent does this kind of approach of explanation provide some new insights or different insights into ontology evaluation?
Oh, that's really a great point, right? Because I mean, I think there are 2 things I would like to say. So the first one is, I think it's so the first point is by revealing so one issue of evaluation that Nicola focused on is to guarantee that your model as a representation, right, of a given conceptualization is such that it has, it comprises the exact set of constraints that would make its possible interpretations the intended interpretations, right? So you would like to avoid an under or over constrained model. So the design of the model has to follow the conceptualization at hand, right? So the project of explanation is the project of making explicit the conceptualization that you're going to follow in order to guarantee that you have the right set of constraints. That's the thing that has to be approximated in your set of constraints, right? The second thing I would like to say is that from a quality point of view, I think 2 essential, but kind of unexplored aspects of quality of ontologies are this one. So to guarantee that your ontology has the right constraints, to approximate as much as possible the conceptualization behind that. But I would put as a second quality criteria, and the 2 things are connected, is that your ontology should be an explanatory model, right? Your ontology shouldn't be just a descriptive model. For all the propositions in your model, the truth makers of those propositions should be explicitly represented in your models. As you do that, you open up possibilities for a deviation between the 2 sets, the sets of the set of possible and the set of intended models. So it's playing a game by explaining, then you know what are the constraints that you should include that. Does that make sense?
Yeah, no, great. I think this is really interesting kind of angle to kind of revisit some of those questions. So yeah, thanks a lot.
Thank you.
And Barry, do you have comments?
Yes, I was trying to switch on my video, but it says that the host has stopped it.
I think we can correct that. Ken is usually
Not a
on top
big
of those
deal.
things. Making you a co-host, I think, would do it.
You should be able to
yes,
start
good.
your video.
Yeah, it did work. Hi, Barry. Nice to see you.
Hello, can you see me?
Yeah.
No, I can't see me.
We
All right,
can
good.
see
So
you.
I would have a lot to say, but in the interest of time, I will just focus on my problems in understanding your use of the term truth maker. So the proposal that we made in 1984 was that the truth maker for a proposition is that in the world which has to exist in order for the proposition to be true.
Yeah.
So let's take your example, which I didn't quite understand, but it was something like the Brazilian Congress had been attacked. Let's just take that, assume it's true. What has to exist for that to be true is a certain process, which is an attack process, and the target of which is the Brazilian Congress. Basta.
Yeah.
Now you say that the truth maker is how the world has to be like in order for the proposition to be true. Now, how does the world have to be like? What does that mean? I could talk for hours about the Brazilian Congress and what it has to be like in order to be attacked and so on and so on. So it doesn't seem that you have a clear idea here.
No, maybe I didn't. I thought I was making the idea easier. I thought I was
No,
facilitating.
you're making it much harder.
by
You're talking about
phrasing
the whole world.
no, that's not what I meant. So maybe I didn't phrase this in the best possible way. I agree with what you just said in this particular example, right? That the truth maker of that would be a process in which the Brazilian Congress participates. And maybe, you know, there are some intentions attacked, refer to an intentional event and so on. But I think we agree on that. I think the main, but the difference between the classical notion of truth making and the one we're using here, which is this notion of weak truth making, is that clear in other examples?
Sort of.
So
yeah, you have a tendency to use technical terms in a slightly different way from the way they are normally understood. So.
no, I mean, let's take the example I was using, which I think it's simple enough, right, for us to exercise this distinction there. So this idea that the rose is red, in the approach you proposed, the truth maker would be a situation in the world with the rose being in a certain way, right?
It would just be the redness of the rose, which is a quality. If you have that quality, you also have the bearer, because the quality is dependent on a bearer. So typically simple sentences have dependent continuants as their truth makers, or processes, as in the case of the attack. The attack is a process.
Yeah.
This
so
particular attack is an attack on the Brazilian Congress. That comes free, given that the process always has a participant.
Yes, but in this case, so there is a difference between the existence of the quality or the quality being in a certain way, right? So it's not just the sheer existence of the color quality here in the rose, but that quality being in a certain way, namely having that value or that state, or being constituted by a given redness trope. I don't know.
So it seems you're just adding terminology. What we're saying is, what makes it true that the rose is red is the redness of the rose. Now, what are we missing when we don't say more than that?
So let's leave it like that. I think we are agreeing. I mean, the redness, I mean, of course, the devil is in the details, Barry, but I think we're we would need more time. So the redness, the question is, what is the redness of the rows, right?
But so we can know what the truth maker is without going any further into details about the redness. If we do go further into details, we may miss the target. If it's a particular shade of red, then the rows could have been red without being that shade. So we don't want to be more specific than the redness of the rows. That's all we need.
That's not what I meant. But what is the redness of the rows here, in your view?
That's a very deep question. I don't want to go down deep question avenue.
I think Nicola wants to add something.
Yes, yes. His hand is up.
Yeah, the point is the difference between the redness of the rose and the color of the rose. Okay, the redness of the rose maybe is a state of affairs. The color of the rose is an aspect, a relevant aspect of the rose, which is responsible for the fact that the rose is red. Okay, the color of the rose may be responsible also for other things, for the rose being dark or whatever, being black.
So what makes it true that the rose is red is that the color of the road is responsible for the rose being red. Is that right?
Yes, the color of the...
Sorry.
Yeah, okay. It sounds as if you're just adding 6 words to what you can already say with far fewer words. But anyway, I've said enough. So.
Okay.
But the real understanding will come if one talks of why and how the reflected light reaching you is red for red roses. So that understanding is inherent before you can understand why the rose is red.
Let me just interject. We have some questions or comments in the chat, but I wanted to ask one question, if I could, of Giancarlo. From last week, you made the point, as Nicola, after Nicola's presentation, about the fallacy that some people think that having few axioms makes for flexibility.
Yes.
And there's a vagueness there. But your earlier work points out, or at least discusses, ontology design patterns, which is often the case of less axiomization to it. And you also mentioned patterns like participation in your talk, and there's others like situation and so forth. So I'm just wondering what you think of ontology design patterns and your axiomizations now in light of your recent work.
Yes, so great question. So coming back to the, maybe people were not there. So the point I was making is that people have this illusion that just by having an under-constrained model, this is giving you flexibility. What they don't realize is, because making an ontological commitment is inevitable, what they're doing is to commit to an ontology which might not be the ontology they want to commit to. So the ridiculous example I gave last week is like, imagine if you have a model with one class and one relation, and you say, person can be married to 0 to many people, right? And vice versa. People think they are being flexible, but they are actually committing to an ontology of marriages in which anything goes, that you can marry several people at the same time, some of which are dead, yourself, and so on, right? Design patterns are, so the way I see ontological design patterns, I mean, design patterns are unfinished in a sense, because they are structures that are meant, they are structures which are recurrent in different models, right? So they will have to be, you know, supplemented with other constraints which are, which have to do with how that pattern manifests itself in that particular domain. The way I see the design patterns we deal with is that they are representations of foundational theories, of micro theories, right? So for example, in the language I was showing you here is this language called OntoUML, which is designed following the Unified Foundation Ontology. And this language is a pattern language, right? So you build models in OntoUML by instantiating these patterns. And these patterns are representations of the micro-theories comprising that ontology that are part of that foundation ontology. There is a connection between the patterns which are useful there and these explanations, right? So there is a pattern that I just showed you on how to explain material relations, which is by revealing these relators, the connections between these relators and this cardinality constraints and so on. There is a pattern that would reveal these phases and roles and events and process and so on. So the patterns are also useful devices for doing this operation of explaining fragments of the model, reveal the truth makers behind fragments of the model.
Great. Maybe we can take if you have time, take some of the chat questions and comments in the order. Italo had one on how to make these ideas operational, useful to computer scientists. You might be able to see that, or Italo may be able to speak and articulate it as he wishes.
Okay, you hear me?
Yes.
Sure.
So I think that was a very insightful talk, and the paper is also very insightful, and I really appreciate that. And I would like you to elaborate on how to make these ideas more operational, how we can build applications based on that. What do we gain as computer scientists?
Italo, so let's start with the second question, right? So what we gain from computer science, as computer scientists, we make models that are interoperable, right? We make models that have a better quality because we know exactly what we are talking about. So they are better representations of the domain at hand. And they guide us in finding out what are the constraints that should be included in this model, right? So the models that have this, you have to think that the role of ontologies, the primary role of an ontology is not to structure data. I keep telling people this. I mean, this drives me crazy sometimes. The primary role of the ontology is an explanatory role. It's to support people in tasks like domain understanding, problem-solving, communication, and explanation, so that people understand what is the conceptualization which is externalized in that model. Without doing this, we cannot solve this problem of interoperability. How do we bring theory to practice? I think this ontological unpacking methodology is a path in that direction. What we need to do, so as you know, right, we have been building from the foundation ontology from UFO, we've been building a whole ecosystem of tools, starting with OntoUML as a modeling language, but as you know, tools for verification, for validation, for code generation, for axiom learning, for verbalization, all that. One thing that we didn't do yet is to actually explicitly via a tool help people in this process of explanation, like doing the operations I was talking about. Take a model. When you are redesigning, when you are unpacking an existing model, take this model, break it down in a number of propositions, and you help people to instantiate the patterns that would explain each of those propositions, help people verify the model, simulate the model, find out what constraints are missing, and so on and so forth, right? So in a sense, it's revisiting the tools we already have, from this point of view, with under the light of this explanatory strategy.
Thank you. We have some comments from a person, JFDEL. Maybe they could say a few things about their questions and comments. No?
Mike Bennett wants to say something, I think.
No, I was just following up the question about making technologies useful to computer science by saying, well, for your application, you need to identify what I call data surrogates. What kind of data would exist in your realm of data if and when the things you've identified in reality as the truth makers are in play? Stand those up as a separate logical RDF, OWL ontology, or relational database, or whatever, and then you have traceability between your different kinds of model. So it was really just sort of a follow-up to the last question. I didn't want to jump in and get in the way because there's lots of more questiony questions in the chat, I think.
I think,
Al
thanks for
can,
mine.
yeah.
I was going to
has
say that,
something. Sorry,
sorry.
go ahead.
I was going to say that this connects to one of my last slides. So this idea, right, that you break it down in propositions, you do the unpacking, and then you find data as evidence of the existence of those truth makers or not, right?
Right, data as evidence. That's a good point. Thank you.
Alakan has some comments from the semiotic.
Yeah, thank you just for the talk. Actually, I already seen the other version, I guess 2 days ago. But my question is, I'm also struggling with the explanation because I'm working on the business field, and most of the concepts which they are using are ambiguous, so to speak. So that I'm trying to, let's say, formalize the definitions. And the technique, what I was using is I'm actually using the dictionaries, lexicons, and so on and so forth to get definitions of the concepts and formalizing them. Isn't it also like some sort of explanation in the sense? And what do you think about this methodology? Thank you.
Yeah, thanks for the question. So, I mean, it depends, right? Because you have to make sure that what you're doing is not to just, replace one description for another description, right? The terms that's sometimes what dictionaries do, right? So you're just replacing one description for another, but you still have to deal with this Y regress I was talking about, right? So you have to, again, move from language, from symbols to the entities in one's ontology. I imagine that this is really a problem in practice for someone working in the domain you just mentioned, because in these social legal domains, basically all terms are polysemic, right? And in a very systematic way. So Nicola mentioned last week about service. We did this work together with João, who's I think is here as well, with João Paulo. So take just this term, right? Service. So what do you mean by service? So you have to do an analysis of the concept and understand how the different reference, that could be different reference for the same term, are related. So are we talking about the service offering, like Vodafone is offering one, high-speed internet for 50 euros, a type of relator, binding the provider and a community of target audience for that service? Or are you talking about the specific service contract I have with Vodafone? Or are we talking about the execution or the delivery of that service, right? The manifestation of that contract? How are they related, right? So at the same time, you are talking about all these things. So you're talking about service offering, service agreement, and service negotiation, and service delivery, and so on. And these are objects of different kinds, right? So some of them are relators, are just relational aspects, these bundles. Some of them are process and events, and we have to find out. So we have to flesh out what these terms are referring to and how they are connected, right? So this is absolutely essential. But I would pay attention to this, right? To make sure that I'm actually revealing what are the entities I'm talking about and not just replacing descriptions for other descriptions.
We have maybe time for one more question. I'm not sure I can see the hands, but does anybody have a burning comment or question?
Nicola wants to add something since he's the co-conspirator in this project.
Yes, repeat the question, sorry.
No, it's not a question. I'm just asking if you want to add something to what I said.
Well, I was writing on the chat trying to clarify more what a weak truth maker is. A weak truth maker is is something which is responsible for the truth of the proposition, but not necessarily its very existence entails the truth of the proposition. This is the difference between strong and weak truth maker. A strong truth maker, the existence of the truth maker entails the truth of the proposition. The existence of the weak truth maker not necessarily entails the truth of the proposition, but it is responsible. Depending on how it is, then the proposition will be true. Anyway, I pointed to a paper on the chat. Another thing concerning the original question by Michael, how this notion of explanation is related to the evaluation of an ontology. It is related with respect to the notion of accuracy of an ontology I introduced in my previous talk. An explanatory ontology is more accurate because there are more entities indeed. It is closer to the conceptualization, and therefore it is more valuable. It has a higher value exactly by being more accurate.
That's an excellent point, Nicola. If I can add something to which I think Michael will appreciate as well, is that, I mean, one thing that I didn't have time to talk about that we discuss in the paper is that, you know, explanations have to take into account the background and the goals, the interests of the explanation seeker, right? So we also connect to this idea of pragmatic explanation, in which you, in a sense, to explain is to answer these why questions by explanation seekers. We very briefly discussed this, but I think that we should look at competence questions as requests for explanation. So instead of, you know, as deviating from the original idea of Michael and Michael Wu showed in the original papers, people start formulating competence questions as mere lookup queries, right? So things which can be directly translated into queries. That always puzzled me, because if you can translate these things to queries, you know already what the ontology looks like. So they cannot play any role as a kind of set of requirements for the ontology, just as a testing mechanism. But I think we should revisit this idea of what is the real role of competence questions, and I think we should look at them as requests for explanations in this pragmatic sense.
Great. I think Michael Gruninger has left us, but perhaps you can raise that question next week when he is our speaker.
Great.
And with that, I want to thank you again, Giancarlo, and I thank everybody for showing up and the wonderful discussion, and look forward to seeing people again next week.
Thank you very much. Thanks for the invitation. It was a pleasure to be here.
Thanks, everybody.
Bye-bye.
Bye.
Thanks, everyone.